We're going to use this too in introduction.
Yep, you'll do that. You'll stay up here at the podium.
Right.
I'm probably, you can't start until I give you a thumbs up, so I'll come over by the camera and give you a thumbs up.
Okay. Very good. We're not going to pass a plate. You can sit in the front. Yeah, I understand that. We're waiting on some technical issues to be resolved out here. You can always walk back in. You won't bother us. No, we've been here before. There you go. Ready? Well, good morning, people. They got it all resolved. Just for your information, this is being streamed live on Facebook Live around the world this morning, so don't say anything ugly this morning. So, I'm Boyd Dingus, the General Manager of ESTROTECT, and I'm fortunate to have been with this since the day it went to market quite a few years ago. We're here today to talk about our new ESTROTECT Breeding Indicator and the science behind it and why we have that product today. The ESTROTECT first became available in 2006. It's an adhesive patch that's affixed to the back of a cow between the hips and the tailbone. And when the cows are mounted by other cows, it rubs off like a scratch card and reveals the amount of times that the cow has been mounted for AI and for embryo transfer for recipients. It's been used more than 70 million times around the world, and that's a low number as we continue to move forward. And the new product has already been used millions of times because it was actually launched a year ago at this show. But it does a lot more than just detects heat, which is what we'll talk about today, and our speaker will address some of those issues. So we know things today that we didn't know, and that's what science is about, to help move us forward and teach us things that we didn't know. We know more now than we did in the Curtis Breeding Service days, as we were talking about here earlier. So the ESTROTECT Breeding Indicator is very similar to the original product, only it has a precision-based breeding bullseye attached to it, and you'll see the science behind why we've done this. And when this bullseye or that amount has been rubbed off, it's time to start your AI protocol, so it becomes a self-reading device so anybody can interpret this and figure out what to do with it. It's a smart product, as we've said. It's precision design, and it's based on science that you'll see and hear about here in a little bit. It was born from science. And a quick story, this product actually, you hear stories about how products are developed. This product actually started in a bar room in Austin, Texas with a napkin. And we sat down and talked about it for a long time, but the challenge was it took 3 years to develop it and test it and get it to market. So it was tested on more than 20,000 cows before we ever brought it to market. So we knew what it was and knew it worked. So it's a true breeding indicator, as you'll see the science behind it, and you won't have to just take our word for it. This morning we have with us Dr. Ky Pohler, who's assistant professor at Texas A&M University. Ky got his MS and his Ph.D. in reproductive physiology at the University of Missouri. He was at the University of Tennessee for a short time. He's always been focused on reproductive efficiency in cattle. Specifically, he's looked at pregnancy loss and management strategies for pregnancy success. Embryonic loss has been talked about my whole career, which you can tell has been quite long, but nobody ever really did anything about it and really tried to find out what was behind this. So Ky does a lot of hands-on research, university research, and it's done on 2 continents because he's also on the staff at universities in Brazil as well. So he works in South America as well as North America. So he's done this on all kinds of animals. So with no further ado, we have Dr. Ky Pohler with us this morning.
All right, thanks Boyd. Thanks for that introduction. So the goal I have this morning is to share a little bit about, specifically talking about some of the things that we work on in my research lab at Texas A&M, and really how that plays into the story of managing reproductive efficiency, and specifically some of this work and things that have gone into the generation of the new ESTROTECT patch, and really I think it's a really unique product in that it's a precision-based, agriculture-based technology that's condensed down into a patch that's pretty simple to use, and I'm going to show you the data that really went into that and what led to that point. So if we think about fertility in dairy cattle and cattle in general, as we go through different periods of pregnancy loss, there's pivotal periods along the way where loss is higher than others. And so I just have this slide here representing that as we go through, and this laser is not going to work here, so just kind of follow me through here. As we go through and we breed a group of animals and we look at fertilization rates, so this is sort of the ability of sperm to get to that ovulated oocyte and to initially fertilize. In dairy cows, it's somewhere between 75, 80 to 85% of the time that happens, depending on the situation, depending on heat stress-based issues, etc. But if you think about it, it's relatively high. Now, as we get out past that point, we get out to the first time that we can do a commercial pregnancy diagnosis using a milk-based PAG, an ultrasound, palpation, whatever it might be, and there's a significant amount of loss that comes along. And this is some data summarized by Milo Weltbank's group in a big analysis where they've shown that about 30% of the loss that we account for as we go throughout gestation occurs in that first 28 days or first 20-something days. And so we characterize this as early embryonic loss. This is loss that we really never even see. These cows normally cycle back around. Doesn't really, when you think about it in the big scheme of things, affect us in our operation because we move forward, rebreed those cows, etc. As we move forward and go from day 28 to day 42, so these are animals that we've identified as pregnant. We've either seen a visual embryonic heartbeat or they've had a positive P1 along the way, and we come back to a P2 or they end up on the breed list where they've experienced late embryonic or early fetal mortality. So these are those cows that are confirmed pregnant and go on to lose a pregnancy somewhere in the next 1 to 2 months. And if we think about this represents about 12% of the loss that we see in dairy herds. If we think about this 12% cost us a lot of money because those animals go a pretty long ways and then end up open. So they're eating the same amount of feed, basically getting everything treated the same as an animal that's going to go on to carry a pregnancy to term, but they lose along the way and have to be recycled back around. So what I'm going to talk about today is talk about these two specific areas and really in this black box and how we got to working with ESTROTECT and how we got to the product that we're using today because of trying to understand really why this loss occurs. So I think one of the really unique things of the story that I'm going to share with you today is when I first met with Boyd in Austin, Texas about this idea to generate a product, it was to generate a research product. We really had no idea that we were ever going to do anything as far as working with it and taking it to market. So I think it's a unique story in that case. The other thing that I want to point out is as we learn more about pregnancy loss, we're learning a lot more about when it actually occurs. And so these are two slides that I brought along to point out that as we get from even day 24 to 31, very short period of time, a week alone, all right? I'm going to show you the data in lactating cows and I'll show you the data in heifers and dairy heifers. Look at the amount of pregnancy loss in just 7 days. This is a set of lactating Holstein cows in Brazil where we experienced 20% pregnancy loss from day 24 to day 31 alone. So if you could even decrease that by 10%, you're catching a lot more animals to get, that are going to move forward. So a lot of loss occurring in a very short period of time. Same thing is true on the heifer side, where we get and look at heifers here. We have a situation where we're basically doing the exact same thing as the slide before, but in heifers it's a lot less. We see only about 11% of the time do those animals lose a pregnancy between day 24 and day 31. And so the point that I want to show with these slides in conjunction with the slides before is that there's a lot of loss from 24 to about day 40 to day 60 of gestation that's concentrated in that period of time. And that's really been the area that we have focused in. We've thought that the cows that normally cycle back around and are able to get bred in the next cycle, those really aren't an issue. Those follow the normal parameters. They so-called read the book, right, within a dairy system, and everything sort of fits the system. It's these cows that experience pregnancy loss from 24 to 42 where they might not be cycling back in a normal situation. They might have an extended period to where we're going to breed them again and cost us, more days open and more money. So when we think about it, one of the things I want to talk about today is management strategies of pregnancy loss. All right, and so how do you manage pregnancy loss? How do you deal with it? Because I don't think we're ever going to be in a situation where we can prevent pregnancy loss from totally occurring, but there has to be ways to manage it. And so I'm going to talk specifically about managing it through estrus and estrus detection and estrus intensity. And so when we first started in these projects over 10 years ago now, looking at estrus intensity and pregnancy success and estradiol and pregnancy success, we developed a scoring system used on a 1 to 4 scale, where 1 would be the patch had 0 to 25% of the patch actually rubbed off, 2 was 25 to 50, 3 was 50 to 75% of the patch, and 4 was 75 to 100% of the time the patch was rubbed off. And obviously you can see just looking at these scores here, and I'm going to show you some real examples of these, there's some bias that goes into reading these patches. So you're standing behind the cow and reading them. All the projects that I'm going to show you today have been conducted with time AI protocols. All right, so we have done all time AI protocols to do the work that we're doing. We read the patch at the time the cow is AI. So that's a really important clarification there. We also, when we put these papers together and we put the data together, we were also summarizing at the time basically cows that had no estrus or low estrus intensity, patches of 1 to 2. So that would have been a score or scores of 1 to 2 or less than 50% of the patch actually rubbed off. Or scores of 3 and 4, in that case we were calling them high estrus intensity, or a cow that had exhibited estrus. And this would be the scoring system that I use for all the slides moving forward here. And when we first started looking at this, there's been a lot of work done in this area, and this is some of the first projects that were done with the patches and this sort of scoring system to look at this set of data. Where we have estrus, no estrus, we have a time AI situation, first looking at fixed time AI, where we have pregnancy diagnosis at day 32, day 60, and then pregnancy loss. This pregnancy loss is representing cows that were confirmed pregnant at day 32 and then lost their pregnancy between 32 and 60. And so you can see here in the blue bars, the estrus cows, they had increased pregnancy at day 32 and day 60 compared to the cows that didn't show estrus. And as we get over to the pregnancy loss side of things, the cows that didn't show estrus had increased pregnancy loss. So if we summarize this, displaying estrus and having high estrus intensity increased initial pregnancy and also decreased pregnancy loss. If we look at that on an embryo transfer situation, this is a fixed time embryo transfer situation where we're transferring embryos at a given time, just like we're doing fixed time AI. Day 32 and day 60 set up the exact same way. You can see the increases in pregnancy rates in the estrus groups compared to the no estrus groups, and the exact same trend in that the cows that did not show estrus also had increased pregnancy loss. So the exact same story whether it was in time AI or timed embryo transfer. Now as we move across here, we've summarized a lot of data from a lot of different sources, both from AI, embryo transfer, all into one slide. I put this together about a year ago when we were looking at the effect of this patch score across all different breed types, across all different management systems, across places in Brazil, across places in the US, and this is what the data looks like. So here we first have Brazil, represents about 25,000 to 50,000 cows in this slide, depending on the country. And as we go through Brazil, you can see there's a nice linear increase as we increase patch score to increase pregnancy establishment. So it fits the exact same bill that I was talking about earlier. And as we look at the US, you can see it's not as steep as we go up, but those cows that definitely have high estrus intensity with those patch scores of 4 have a completely activated patch. They have increased pregnancy rates to patch scores of 1, 2, and 3. So across the board here, we see the exact same results utilizing the patch scoring system in regards to pregnancy establishment and pregnancy maintenance in these cows. Now the thing that we were interested in, because my lab is interested in pregnancy loss and trying to understand the mechanisms of pregnancy loss, is we wanted to know what did it look like in a pregnancy loss situation. So we have all this data now from all these different patch scores. We've really felt like we dialed in the precision for being able to identify those patch scores. And so what did the pregnancy loss look like? Well, in the patch scores of 1 and 2, which we characterize as this low estrus or no estrus at all, they had increased pregnancy loss between that P1 and P2 period compared to cows that had high estrus intensity or a standing estrus and had an activated patch of a 3 or 4. And so if you look at that and you look at what these visually look like, this is basically the scoring system excuse me, that we were using visually. So you can see here these first 2 patches in 1s and 2s, you can definitely tell that 50% of the patch is not rubbed off, right? I mean, it's pretty visible to see that. Versus in the 3s and 4s, you can definitely see that there's a lot more of that patch rubbed off. but it was getting harder and harder to sort of score these patches in the field, different variability. And so this is when I sort of got together with Boyd and the folks at ESTROTECT to try to develop something that made it easier on us from a research point of view to identify cows that had at least 50% of the patch activated or last 50% of the patch rubbed off. And that's gotten us to this point today, utilizing the breeding indicator with the breeding bullseye. And as we go through this, the patch scoring system that we were using fits this identically. So here in this situation, this first one here where the bullseye is completely non-activated would be a patch score of 1. As we get to the next patch there, we're between 25 and 50% rubbed off, that would be a patch score of 2. And then as we get past that point, we're getting into patch scores of 3s and 4s. But the idea was that the bullseye itself represented what 50% of the patch was. So it allowed us to visually and easily see the patch, but also develop a piece of technology that really has some precision to it, that has a lot of data backing it up in regards to what's there. And so this is the current product in its current form based on all those slides moving forward, or that I showed you before. So the other thing that I want to talk about is show you a little bit more data on the pregnancy loss side of things. And I think this is probably what's the most exciting point to me, is that not only are we seeing effects in pregnancy establishment, but we're also able to decrease pregnancy loss and see some other physiological markers that are pointing toward the idea of decreasing pregnancy loss. So one of the molecules that we use, or one of the proteins that we use, are pregnancy-associated glycoproteins. And if anyone is using milk or blood-based pregnancy testing in your operation, that's the basis for those tests. PAGs have been around and were originally discovered when we were trying to develop chemical-based pregnancy tests. And we have published a lot of data, a number of people have published a lot of data to show that these are directly correlated with pregnancy success. And so what we have seen is that as you have high PAGs early in gestation, you have an increase in the chance to have a successful pregnancy, versus if you have low PAGs, you have an increased chance for pregnancy loss. And it's not that simple, but it's a correlation there with that. So we've used them as a way to monitor pregnancy success and pregnancy maintenance and pregnancy loss, with the idea being that when you have low levels early in gestation, that's not good for the developing pregnancy, and that cow's at an increased risk to lose her pregnancy. And this is just showing a picture of PAGs. They're secreted by the placenta, and this is the cell type here that secretes them. You can see all those little black dots within that cell represent the PAG protein itself. Now, one of the things we wanted to look at is patch scores in regards to PAG production, because like I said, we had shown previously that as PAG increased, you had an increase in pregnancy success. And so this puts together about 10 different studies here summarizing some of the dairy projects that we've done, looking at PAG. So here's PAG level on the axis here, the y-axis, and across the bottom here I have patch score 1, 2, 3, and 4. And just remember, when I talk about the patch scores, you can relate that to the bullseye by just saying that the 3s and 4s of the bullseye have been active because that's over 50% of the patch being rubbed off. Okay, so just keep that in mind. So in this situation here, we can see as patch score increases, so as we increase the estrus intensity, as we increase the amount of rubs that cow has had, she increases the amount of PAG that she has in circulation, which if you correlate that back to the physiological data, shows that as estrus intensity increases, as patch score increases, you get an increase in pregnancy success, and the physiological role for pregnancy success is also being shown there. So all that coming from a patch, right? So that's sort of the amazing thing, I think, and the thing that is really neat when I think about it. This is another set of data showing the exact same thing. As patch score increases, you can see that correlated increase with pregnancy at day 30 on the left axis over there, and on the right here, we have the exact same PAG story in this case. So again, fits together, tells a story in regards to sort of pregnancy establishment and pregnancy maintenance. Now I want to switch gears a little bit and talk a little bit about another major issue that I think everybody, both in the beef and dairy industry, is facing in regards to pregnancy success and maintenance. One of the things we know is that the sire itself and sire fertility can be quite variable. And this represents about 50,000 matings from a couple large dairies that we work with, where I have both pregnancy rate, so this is an initial P1, and I have pregnancy loss, okay, so a P2 or some follow-up preg check in order to determine cows that underwent pregnancy loss. And the red lines here, the maroon lines, represent the pregnancy rate, and at the bottom is an individual sire. So each of these is an individual sire, and in this case, each one of them had to have over 250 matings. So as we go through here, you can see pregnancy rate is really all over the board, and I have this graph graphed by the amount of pregnancy loss. Okay, so this is pregnancy loss between a P1 and a P2. And what I want to draw your attention to is there's no correlation between the establishment of pregnancy, between a positive P1 and a P2. So these bulls are kind of all over the place with initial pregnancy rate and pregnancy loss. And this is something that was quite surprising to us, and something that we're also following up and looking at in regards to sire fertility. But what I want to show you here is pregnancy loss in these bulls ranged from 6% all the way up to 37%. There's a huge difference in pregnancy loss. If you just look at the pregnancy loss alone, the variability in pregnancy loss is way more than the variability in the establishment of pregnancy. And so one of the things that we were interested in is how can you minimize this variation in pregnancy loss from the sire point of view? Do these sires have different effects when you use them in fixed time AI or AI-based protocols, whether the cow is in estrus or not in estrus? How about sex semen? How does sex semen come into play? Does sex semen have better results if the cow is in estrus or not? And so that's really what we set out to start to utilize the patch for, is to make some management decisions behind the cow to help us advance ourselves forward to not only increase pregnancy rate, but to decrease pregnancy loss. And so I'm going to show you a few slides associated with this. The first study I'll show you here is a study that came out of Canada from some colleagues looking at the effect of using sex versus conventional semen in an estrus versus a no estrus situation. And so a lot of times when we talk about the use of the patch and talk about a management strategy behind it, we realize that the cows are coming in for maybe a time AI, and there's going to be cows that have an activated patch and cows that don't have an activated patch. And if you're doing a time AI, you want to do something that day in regards to breeding the cows. And so on the beef side of things, what we're currently recommending, because of some of this data, where if the cow is in estrus, there's not a huge difference between the fertility from sex versus conventional-based semen, versus if the cow is not in estrus, you can see a big difference there in regards to sex versus conventional semen. So the cow comes in, she's standing in the chute, she's in estrus. In that case, I could probably go ahead and put a straw of sex semen in her. If she's not in estrus, then on the beef side of things, or even the dairy side of things, I could use a conventional straw or potentially even a beef straw of semen. So there's options there as we stand behind the cow to make some of these decisions in order for us to get more cows pregnant and have more pregnancy maintenance as we move forward. So this is one example here. This is a number of studies now that we have done looking at this in regards to pregnancy loss in these sires. So remember, I showed you that big variance in data on the dairy side, on the dairy bull side of things, with pregnancy loss and pregnancy rate. So now we've gone in and selected individual sires to specifically look at them in a situation where we can definitely track whether the cows come in estrus or not, basically using the ESTROTECT Breeding Indicator patches here, the bullseye patches. So in the situation of the maroon bars, the cow that bull's being used in has not had an activated patch. The bullseye has not been activated, so it's a patch score of 1 or 2, versus where we get to more of these lighter colored bars, the bullseye has been activated and the cow is in estrus and has high estrus intensity. Each one of these 1 through 9 here on the bottom represents a different sire. And as you go across here and you look at these, 8 of these sires perform better in the situation where the cow showed estrus, had an activated breeding bullseye, versus when they did not. And this is all conventional semen in this case. Okay, so no sex semen here. So again, showing that if you look at the situation of initial pregnancy establishment and pregnancy rate, as you go across the board, those bulls that are the cows that show estrus, the bulls perform better in them than when they don't show estrus. Right? So going back to that exact idea of sort of making a management decision behind the cow. Now, as we look at it in regards to pregnancy at day 31, in bulls that have high pregnancy loss, high late embryonic mortality is this first group here on the left, versus low pregnancy loss or low late embryonic mortality, what I want to point out is that these bulls that have high pregnancy loss, if you look at their estrus versus no estrus situation, the bulls that are having high embryonic loss they perform a little bit better in the estrus situation compared to the no estrus situation. But where we see a really big effect is on the bulls that have low pregnancy loss. Okay, so this is after day 31 in that P1 to P2 region. These bulls that have are used in cows that have an estrus situation have a lot higher pregnancy rate at day 31 compared to the cows that don't show estrus. And so I show you this sire data because, not only are we talking about managing cows to not lose pregnancy, we know that there's sires that perform better in situations that the cow is in estrus. We can always find bulls that perform equal, and I showed you an example, that bull number 4 on the slide before performed about equal in an estrus, no estrus situation. But for the big scheme of things, as we look across all these sires in our hands, a lot of them perform better in an estrus versus a no estrus situation. So again, standing behind the cow, being able to utilize and make a management decision to cut down on the amount of pregnancy loss that you're having, but increase your overall reproductive efficiency. Now, the last slide that I have here is some data that we've just finished in collaboration with Ronaldo Sehi's group at UBC in Canada. And I think that this is something that's really useful, and is something that can really help us a lot from the embryo transfer side of things. So a lot of times we get a lot of questions in regards to what about estrus intensity in our donors, all right? And the data that I showed you before was all in cows undergoing time AI and a little bit of timed embryo transfer. And across the board in AI and embryo transfer, estrus intensity with the patches follows the exact same idea that you increase pregnancy rate and decrease pregnancy loss. But what about donor animals? Animals that, we're never really trying to establish a pregnancy in to begin with. We're just trying to produce more embryos out of. And so one of the things that we did in this study, or the graduate student Augusto did, is looked at cows that are donors that had high estrus intensity or had an activated patch, had an activated bullseye at the time of the initial breeding, right, when we did the initial breeding for the embryo transfer, versus cows or donors that did not. Okay, and so there's about 70 donors represented in this case. They're heifer donors. And I just want to go through this. I'll start out with the number of follicles here on the right-hand side. The number of follicles in these cows was slightly increased in the cows that had an activated bullseye, had high estrus intensity, compared to the animals that did not. All right. So as we start out, even before we ovulate, we have more follicles that are on the ovary that have the potential to ovulate. I don't have ovulatory response on here, but in these donors that had activated breeding bullseyes, they also had an increased ovulatory response, which means that they ovulated more follicles than the cows that did not have an activated patch. All right, so that's the beginning part, because we have to have that to start out with in regards to embryo production. Now as we look at number of viable embryos, so these are the number of embryos that we recovered based on conventional embryo transfer. What I want to point out here is that in the cows or in the heifers that had an activated breeding bullseye, that had increased estrus intensity, they had increased number of viable embryos recovered. Right? So increased number of viable embryos recovered. And as we go out to percentage of viable embryos, so it's the calculation based on the number of embryos collected in regards to the number that are viable or transferable. And in this case, again, we saw a positive effect in the cows that had an activated breeding bullseye. So increased number of follicles, increased number of increased ovulatory response, increased number of viable embryos recovered, and increased our percentage of viable embryos recovered. So across the board from a conventional embryo transfer point of view, everything was positive in the situation where the cow's bullseye or the breeding indicator was activated. And there's a lot of questions, surrounding embryo transfer all the time that we're working on trying to increase the efficiency of embryo transfer. And one of the things is that, we do some things and we get 5% better, we adjust a protocol, we maybe don't get the cow to respond, etc. But something very simple in this case of looking at estrus or estrus intensity of that donor led to an increase in the recoverable viable embryos. And so you might ask yourself, well, I already have an embryo transfer protocol set up. What am I going to do if the donor doesn't have high estrus intensity versus if she does? What would I do to adjust? Well, one thing that's potential is to fall back to the sire side of things. So if you were planning on using sex semen in your conventional embryo transfer, if you have low estrus intensity, maybe at that point you don't want to do that. Maybe you want to use conventional semen or something else. In this case, all these animals, all these heifers were bred with sex semen for the conventional embryo transfers. So again, something to think about, utilizing the patch to get to that point. So I'll end right here and go back to the initial part. So this all started, as I said, and as Boyd mentioned, as trying to develop a test product from a research point of view, something to help us when in the field as we were conducting these large research projects to get an easy measure of estrus or estrus intensity. And where we've ended up today, from that point of view of over 4 years ago, is I think we have come up with a product that really is precise and really is a piece of precision agriculture. As you think about it, it's something that we can apply. The cost isn't very high of it, and you can read it and make management decisions based on what the patch tells you. Whether that's from the sire side of things, whether that's trying to understand why animals might be undergoing pregnancy loss, whether you're trying to understand a breed or no breed situation. The breeding bullseye in these patches is pretty easy to see and is something that you can definitely recognize as you walk throughout the barn. So as we summarize here, as we go across the board, one of the things that we've seen over and over again, and like Boyd has mentioned, this has been tested on hundreds of thousands of animals now, the new patch alone, and really all over the world, both in beef and dairy, in all environmental conditions that you can imagine. And what we continually see as we look at the data across the board is that we have an increase in the activation of the breeding indicator, and really the sweet spot is the increase in removing that breeding bullseye. So once that breeding bullseye is removed, that black dot, you have an increase in pregnancy establishment and you have a decrease in pregnancy loss. So as you sort of summarize that together, you're increasing your reproductive efficiency of your herd just by what that patch tells you on that cow's back. So something that's very simple, that really carries a lot of data with it, and something that we can use to sort of help advance us forward. So with that, I'll thank everybody that's been involved from my group and really appreciate the support and the work that we've done together with ESTROTECT. I think it's really been a great relationship, and we've put a lot of time and energy into getting to this point to really have something that's really helping us understand from a research point of view, but also advancing the industry forward. So with that, I'll take questions.
Just two quick questions.
Yes.
Number one, if you've got a rubbed off patch and let's say it's not detected till that evening and you're not going to AI or till the next morning, how disastrous is that waiting 12 hours before you AR and you've got a rubbed off patch?
Yep. So let me answer that one and then I'll let you. So the question is, I'm just going to repeat for the people that are joining us by Facebook Live. So if you have a patch that you detect that's activated in the afternoon and then you're going to wait till the next morning to breed her, how does that affect sort of pregnancy rates? Theoretically, it doesn't have a huge effect on pregnancy rates, and we have some studies ongoing right now to determine what exactly those effects are. The idea is, potentially you could have a slight increase if you'd breed her that night, but it's probably not hugely detrimental if you wait till the next morning. And we'll know more in the next few months and have a good answer for that in regards to whether it has a really big effect or not. Yeah.
And the last question, how disastrous is it to vaccinate that cow less than 30 days before you breed her with a modified live? Is the vaccine causing problems?
Yeah, so the vaccine story is very complicated, and I'm not a vaccine expert, so I won't get too far off in it, but the thing that I will say is that the farther out that we can vaccinate prior to breeding, I think is the safest way to handle it. And there's a lot of work that's being done in that area to try to fully understand what those roles and mechanisms are. But as we look at it from our situation of pregnancy loss, one of the things that we try to do is take all other aspects out. So in our cows that we're using, we try to remove all that other noise just so we can focus on really what the physiological mechanism of pregnancy loss might be and not maybe what some of the other external factors. Yes, sir. Yes, sir.
I have a few questions.
Perfect.
First of all, have you done any testing of the hormones to understand why there might be more complete patches, the more lit up before versus those zeros? Or
so the question is, what do the hormone profiles look like in regards to patch activation, and we have done some of that. One of the things is that estradiol definitely increases in regards to patch activation. But estradiol is a very difficult hormone to measure because it hits a peak and then it comes down very rapidly. And so when you compare two cows that are coming into estrus, they might have equal estradiol, but very different estrus intensity just depending on where they are in that increase of estradiol. So very difficult to sort of sort that out. On the progesterone side of things, what we definitely see is cows that have high estrus intensity or increased estrus activity is they have decreased progesterone at the time of breeding, and that's been reported by a number of groups and is something that's very consistent.
On the embryo information you had, was that with just traditional flushing or with IVF?
That is with conventional embryo transfer. So those animals were all they were all heifers. They were all stimulated in the exact same way, and they were all bred with sex semen, and the estrus intensity was read at the first insemination when we administered the GnRH.
So say that last part again, what was I guess my question was what the timing was of when the patch was in relationship to the flush.
Yeah, so let me repeat the question here. So the question is about the embryo data in regards to when was the timing of the patch read in regards to timing of the flush, and also was it done in IVF versus conventional. And so the first part is this was all done in conventional embryo transfer in heifers, and the patch was read at the first AI following the administration of the protocol. So it was at a time AI, and on the first AI is when we read the patch score. And we didn't follow them forward from there. Other questions?
Did you have any data looking at embryos being put into recipients with low or high patch rubbing?
Yeah, great question. So do we have any data in regards to embryo recipients with activation of the bullseye versus not, or high estrus intensity versus low? And we do, and we see the exact same effect that I showed with the time AI data. So if you have an increase in estrus intensity, you have an increase in pregnancy establishment, and we probably see a little bit more of a drastic response in regards to pregnancy loss, especially on the IVF side of things, in IVF embryos. The IVF embryos, because you have increased pregnancy loss in them already, I think we see more of it in that situation of animals that have sort of not an activated bullseye and that lower estrus intensity. So that's in situations where we've looked at estrus. We also have timed embryo transfer data that I showed in that fourth or fifth slide that would match that and show the exact same thing. And we've seen it both in beef and dairy embryos in that case, and beef and dairy recipients as well. So.
More questions? Nobody wants to speak in the mic. Oh, you got another one?
Is there any way to get a timing of when that peak is, as far as their heats, their estrus?
So the question is there any way to get a peak timing of when estrus might be? I guess, is there a way to do it? Yeah, you could sit out there and continually watch them until sort of you hit this peak. My feeling is that might not be that critical as we sort of look at the big scheme of things, because you're really in this situation utilizing this. You're trying to figure out, whether those animals are going to hit that threshold or not. And for us, that threshold is getting 50% of the patch rubbed off or activating the bullseye. And once that happens, then from there we sort of get these increases. And as you sort of back up, it is linear from a 1 to a 4, but really you get the biggest benefit as you sort of get over that threshold level. And so yeah, you definitely probably could determine peak intensity or peak estrus by watching them or monitoring their activity, but it'd probably be a lot harder, and I'm not sure that it really would provide you much more than if you just got to a certain point and had a threshold level, if that sort of makes sense of the cows in estrus versus not in estrus. And the other thing that I want to mention that I didn't mention at the beginning is we also get a lot of questions in regards to, well, how well can you keep the patches on in a rain situation and in a heat situation, etc. And we've put on hundreds of thousands of these patches now, and I summarized all of our data behind patch loss not too long ago, and it's less than 1%. And I don't think that we're any better at putting them on than anybody else. It's just that we try to make sure that we clean the cow's tail head a little bit and get them put on correctly, and sometimes they're harder to get off than they are to get on, but it's not a huge issue for us.
Okay, we just have time for one question because we need to clear the room for the next speaker.
What's the price on the patches generally?
Oh, it ranges, and the best is to ask somebody from ESTROTECT because I don't know exactly what they're commercially going for. So somewhere in the $1.50 range, I think, is what they currently are. In the U.S., yeah. It's going to be dependent on the country as well.
Okay, thank you very much.
Move you around for more questions.
Yes, yeah.
But I guess maybe if you could move it.
Far out so that you don't get any feedback.
As far as time AI versus
I'm going to turn this off, Kayla.
watching, your study, if you did studies on that, on percentages of pregnancy versus